Hi girls, it's Miss Stein again looking at covalent bonding for the Year 10 chemistry course. Just a reminder from last time, all substances, remember, are made up of atoms, molecules or ions, and the way the particles are arranged in a substance is described as the structure of the substance, and the structure depends on the nature of the particles present and the forces holding them together. So remember, there are three types of chemical bonds, and they are metallic, ionic and covalent bonds, and they're all held together by electrostatic forces, and these electrostatic forces are always the attractions between positives and negatives. Covalent bonds form between non-metals, and the non-metals have high electronegativity. Just a reminder that electronegativity is the ability of an atom to attract electrons within a bond. So it's not about attracting their own electrons, it's about attracting another atom's electrons. Now let's look at an example. We'll look at the example of fluorine. So when two fluorine atoms combine to form a molecule, both have high electronegativity. In fact, they have the highest electronegativity of any element on the periodic table, sitting at the number of 4.0. Now, this is equivalent to two identical twins pulling on a tug of war at exactly the same amount. So, in this particular case, because they both have the same electronegativity, neither can win the electrons. So what's happening is our fluorine here has 2, 7, and the other fluorine also has 2, 7. So this becomes the electrostatic attraction between the positive nuclei and the shared pair of electrons. Now this can also be drawn in a more simpler manner. Often we draw them just to show the outer shell electrons, and it can be shown like this. But all we're showing is the outer shell electrons, and you can see here that where you have 2 electrons, this forms one covalent bond, and it could also be drawn in a simplified manner with a line to show the covalent bond. Now if you look at these diagrams, you'll see that if you count your electrons, you've got 2, 4, 6, and there's 2 in there, 8. So this fluorine atom believes it has 8 electrons around it, and 2, 4, 6, 8, this fluorine atom has 8 electrons around it, so they form a stable electron configuration. So non-metals combine by sharing electrons, and what the first diagram here is showing is that we've got 2 hydrogen atoms and they are sharing their 1 electron each. This is forming a covalent bond. Each hydrogen now has 2 electrons around it and 2 electrons around this one, which gives it a stable electron configuration. So a covalent bond is the electrostatic attraction. Remember, an electrostatic attraction is a positive and a negative attraction between the shared pair or pairs of electrons, there's the negative component, and the positive nuclei. So what this diagram here is showing is there's the shared pair of electrons, and here's the covalent bond, which is here and here, which is the electrostatic attraction between the shared pair or pair of electrons and the adjacent positive nuclei. So covalent molecular substances, which are more commonly called molecules, are most non-metal elements, e.g. hydrogen, chlorine, fluorine, nitrogen. Notice there's a diatomic. That is so that they can form a stable electron configuration. And most compounds consisting of non-metals only, for example, water. Because remember, a compound has two or more different elements chemically combined. So here's some examples of compounds. So in this particular picture, you've got gas. So it might be something like LPG, liquid petroleum gas, which is C3H8. This one here, you've got sulfur. Sulfurs often exist as S8, and this is supposed to show water.